First question for you guys. What's your definition of a robot as it relates to your work? We'll start with you, Magnus.
Thank you. That's a weirdly complicated question to answer. The traditional view of a robot is, people talk about the sense, plan, act paradigm. Something that senses the world, thinks about what actions are appropriate, and then changes the world somehow through actions. And that was for the longest time the working definition of a robot. But now with embedded intelligence and connectivity, you're seeing toasters fitting this definition, right? So a toaster can actually make measurements and think about what color the bread should be and then change the temperature. So in my lab, we've given up. And instead, a robot is a device that people talk to. So if you talk to it, it's a robot. If you don't, it's a toaster. And it may not be a very useful definition, but it says something about what we're now expecting of our robots, which is somehow respond to us and engage with us in meaningful ways.
Ayana, do you talk to your robots?
Actually, my robots talk to me. So my robots are interactive. And just kind of pushing on what is the difference between robotics of the past and robotics of the now. Really, for me, it's about robots and this whole world of artificial intelligence. And when we started back in the day, those were two different camps, right? Robotics was the sensing, thinking, and acting, and AI was like those machines that did really nothing useful. And now, the worlds are blending. And what is an AI system versus a robotic system? Robotics has an embodiment, but besides that, it's still the same kind of interaction, I think, today. And so now I am a robotics/AI person because the worlds are so much closer.
How about you, Dominic?
Well, I think that sums it up very good. At least for me, a robot is always something that is embodied, that has a physical manifestation. And I think that's important to differentiate between a robot and just a bot, like a chat bot or a software bot. Mm-hmm. That said, yeah, same thing applies. We are now robotics and AI people because those two are converging.
Okay. Let's talk about man and machine.
Human and machine.
Human and machine. Thank you very much. The human and machine interface. How do you have robots and humans working together? What do you think about that? Start with you, Dominic.
Well, I think it's the next necessary paradigm shift because in the beginning, when we started building robots in like 50, 60 years ago in the early 70s, those robots were big, dangerous, and fast machines living in cages. It was basically a robot zoo. Look in a car manufacturing plant. And now, through technological advances in sensorics, you can build robots that feel their way, that can detect collisions, that can avoid collisions. So basically, we uncage the robot. And now we can finally build systems that can work together with humans. And I think this is very important to get to service robotics and finally, hopefully, to the love of my life. Well, my wife forbid, but anyway. So the love of my life, which is Jetson's Rosie, the robot housekeeper, so the robot butler. And I think it's really important that we get to machines that are safe to interact with, and now that's possible, and it hasn't been for a long time.
Ayana, how about robots that you relate with on a personal level?
Yeah, so the robots that I interact with and build are socially interactive agents. And so what does that mean? That means they understand human natures. And in fact, you as people are fairly easy to model. Like, we have norms in terms of what's expected. You laughed because I said a joke. I expect him to laugh, right? Like, I can model that.
It's like I'm running a program, and you know it.
So it's really important that robots understand people so that they can interact, and people then will trust them. Because our machines are not perfect yet, right? But if we have this relationship between robots and people, what happens is people will forgive them when they make mistakes, because they will make mistakes. Unfortunately, we're not at the case where they're perfect.
All right. Magnus.
Yeah, so I want to go back to what Dominic said. So if you look at a KUKA arm, the commercially grade KUKA arm, it's a big mechanical beast, and it does this really well over and over again, right? So spot welding or painting, right? But you want to be nowhere close to this thing, because there's a lot of inertia, a lot of mass, and very little sensing going on. So the robots are caged away. And I like this, the uncaging, as you said, because the robotic megatrend now is the robots are escaping their cages on the manufacturing floors. And almost all interesting robotic applications that we're talking about now have to do with robots on our farms, robots in our hospitals, robots in our homes, robots in traffic, robots on our battlefields, and robots on the assembly lines in the manufacturing floors. But they are together with people. And I actually disagree strongly with you, Ayana. People are weird.
But they can be modeled.
So I'm
Based on personal experience.
yeah, no, but I run a very large robotics institute, and no longer is it enough to have mechanical engineers that understand Newton or software engineers that understand Turing, say, so understand how to think about computer programs. But we need psychologists to be part of the Robotics Institute that can speak Freud, right? So combining computationally the world of physics with the world of artificial intelligence and the world of psychology it's complicated. And for someone like me who likes writing down equations and find people complicated, it's hard because robots, when they're starting to engage with people, ultimately have to understand people, and we're not always doing smart things.
Okay. So speaking of robots interacting with their environment, interacting with people, let's talk a little bit about artificial intelligence and machine learning and deep learning and all the other flavors of it. How do you use AI in your work, and where do you see AI going in the next 5 to 10 years? Anyone, you can.
So specifically, you asked the question, which was, how do I use AI or machine learning and deep learning? And so one of the things I kept saying, people can be modeled. That's about data. And so the way that we look at it is we take massive amounts of how people behave in certain situations. I do healthcare robotics and educational robotics. And so we look at how do doctors and surgeons and clinicians interact with their patients. What does that look like in terms of, are they holding their hands? Are they touching their arms? Are there feedback in terms of emotional feedback and support and empathy? And so we use AI just to kind of model that interaction and incorporate it into our robotic systems. And we're just really at the surface of what we can do in robotics and this blend of machine learning and AI.
So an empathetic, modeling the empathy that a physician can have for a patient digitally through software.
So that's the brain. And again, the robots have brains, which is basically a computer system. And so we're modeling how people, I mean, if you think about it, we are just, well, I would say, we are computers that can walk. I mean, honestly, right? Mm-hmm. We have a heart, but what is that? That's power, right? We have legs, but what is that? That's actually biomechanical structure, which we can put on a robotic system. I mean, we're really, really close to being robots ourselves. In fact, most of my engineering friends are.
I resemble that remark.
Yeah, I'll take it. Yeah, but the thing that has happened in learning, which is rather remarkable, right, is that artificial intelligence as a field has been around for a long time, but it never really took off until we had this confluence of tons of data. Right? There are billions of pictures of kittens on the internet. Right? That is a massive amount of data. And the compute power that goes with turning and crunching this data. Sure. And the combination of compute power and data led to things like deep neural nets that now can actually do things that are quite remarkable. And if you look at where state of the art is in robotics right now, in many ways, the brain part is more advanced than the body part. I mean, if you look at the most advanced humanoid robot on the planet right now, if you give it a little push, it's going to fall over. Right? We're not people. We can go an entire day without falling over. We can walk upstairs. We can walk on grass.
Most of us.
Some of us, yeah. Some of us can wear high heels. Right? There isn't a robot on the planet that is that adaptable and flexible. In fact, I like to think of robots as idiot savants. They're really good typically at one thing, but this idea of generalized artificial intelligence and being able to not only detect kittens on the internet, but cook eggs as well, right? That's just because you're good at finding kittens doesn't mean you can cook eggs. But in humans, we typically make associations about competencies. If you're good at something, you're probably good at something else. But that's not true for robots. So I think in terms of where that particular field is going is we're going to see more and more generalists. We're going to start understanding AIs that can not only detect kittens, but also cook eggs.
Very important to do
Sure.
both.
I have to disappoint you because depending on what you mean by we, our customers rarely use AI because it is a buzzword, and surely they all do on their marketing brochures and everything, but in
Yes.
real-world applications, there is a really small set of applications where they really use it in industrial robotics. That said, we're surely looking into those things. For example, and you already mentioned it, picture recognition, that is something, or voice recognition, so
Yeah.
human-robot interaction through speech recode, that is something where it is really, really promising. But there was actually a really nice citation a while ago by a very important robotics researcher, and so you might know that Google tried to learn robotic motion through deep neural networks, and that is absolutely impressive. But at a conference, somebody got up from the audience and said, "I congratulate you as a researcher to your achievement, but as a roboticist, I feel deeply insulted because why do you try to learn something imperfectly that can be perfectly mathematically described?" So there are algorithms for that. And what I currently see is that we're tending to try to learn everything from scratch because now we have that great technology, which it really is. But on the other hand, we don't really think about why do we really do it. And so there are things where you do need it, where it will be very promising, but there are also things that are better off being described by normal algorithms. And if you just let me interject also with the best robots there, who of you knows the movie Zombieland?
Zombieland?
One or two? Okay, thank you. Thank
Woody
you.
Harrelson.
Yeah,
okay,
exactly.
got it.
Because there is the rules how to survive a zombie uprising. It is always run faster. Same thing applies to the robocalypse. If the robots will do the uprising, if they ever will, the only thing is, the good news is, currently robots can run up to 15 minutes. If you make 16, you're gonna survive.
So really the rule is to be fit.
Yes.
Okay, got it.
Well, I should rethink my diet, but anyway. Yeah, but
All right.
Yeah,
Fair enough.
may I jump in? I'm sorry, I'm sure you have an
No,
agenda.
please.
Let's ignore that. No, but I mean, I think this is actually a really good point. Computationally, we can do a lot of things, but in terms of just having efficient batteries that can last longer. Right?
Oh,
I mean,
yeah.
It doesn't.
So I do a lot of aerial drones, right? And so I have hundreds of these aerial micro drones in the air. I'm lucky if I get 20 minutes of airtime out of those. So batteries and actuators and fingers, right? The human hand is remarkable. We can do dexterous manipulation. We can sense things. There isn't a robot anywhere close to being as amazing as the human hand. And if we can have manipulation, actuation, and power that's even remotely close to this amazing system right here, then, or right there, then that's really where the biggest gap is right now, rather than AI computational. So.
Yeah, I think
Agree.
during the interview, I asked Dominic about, everyone I asked, what do you think about the robot uprising? Because as a guy who works with robots and lives with robots, I often get asked this question: are the robots going to come for us? If AI is going to become sentient and technology becomes our enemy, what do you think about this? And I think I'm going to pose it to all of you, but I remember Dominic and I were talking about this and talking about how people are afraid that the robots will come and take their jobs. Mm-hmm. And so Dominic described to me what a person is from a robot's perspective. You can share that.
yeah. So,
Which blew my mind.
So I think the most important thing is you have to imagine that in the first robotic revolution, in the first industrial revolution, what we did was we needed humans because they were the cheapest and most general machine you could get. They were cheap muscles. Now they completely changed, because now what we need people for is for their creativity, for their experience, for their knowledge. So something that actually machines cannot do yet. And well, actually, I'm a computer scientist, but I'm still skeptical that they ever will be able to model that. So basically, we don't want to replace humans. We need to enhance and augment human capabilities and support them, especially in manufacturing. So in the areas where it is very tedious, where it's very repetitive, very boring. That said, sure, and you were hinting at that, whoever tells you that robotics is not going to destroy any jobs is lying, because it will shift jobs. But the interesting part is we're running out of human labor anyways. So you have to imagine that in 2 years of time, more than half of the German population is going to be more than 50 years old. With Volkswagen, big German car manufacturer, with 200,000 in 2030, from 200,000 employees, 30,000 will have retired. So that 170,000 people will have to do the job of 200,000. And recent numbers of the UN and OECD show that 2045, we're going to run into a global labor shortage. It's no longer a question if we automate, it's a question how we automate. And it's going to permeate our living realm. It's going to be everywhere. So robotics and automation will be there. Unfortunately, sorry, Kuka, it will not just be orange arms, but it will be anything. It will be self-driving cars, it will be drone deliveries, it will be self-adjusting furniture, it will be whatever.
What about you, Ayana?
Yeah, so a little bit about the jobs and then a little bit about the robots taking
Sure.
over. So if you actually do the stats, in 2004 to now, 1 in 10 jobs didn't exist, right? So these jobs that exist now didn't exist even 10, 15 years ago. And again, there's going to be new jobs as old ones are disappear. So that is a fact. That's a fact. And robotics and AI are going to be part of that cause. In terms of the robots taking over, so I'm an optimist, right? And so I believe that the reason why people fear robots is because robots are made in our image, and we typically fear ourselves, right? We isolate others, we don't necessarily like certain classes of people. And I think really what we're doing is we're projecting our own fears on these robotic systems. I honestly think robots can be trained to be better than us. I think they can be more accessible. I think they can be kinder. I think we can teach them more ethical values because we can program them. Whereas we try to program, I have kids, right? You try to program
your
them,
kids?
you know, there's some uncertainty there. You're not quite sure what you're going to get. Well, with robots, we can. So I'm an optimist. I think we can actually have a better world if we're really careful about it and we're very deliberate about what we do with our robotic systems.
Without any bias, a
Correct.
robot. Yeah, excellent. Agnes?
Yeah, so being a roboticist, you're always asked, oh, our job's going away. And the narrative is typically either we're all turning into batteries to our robotic overlords. Right? That's one path. And the other path is...
The Matrix, thank you.
Yeah, exactly. Or the other path is, no, we're going to have universal income. We're all going to sit in our beach houses and paint rainbows. Right? That's the other path. But the reality is actually, luckily for us, somewhere in between. Right? We have an opportunity. So first of all, the robots are coming. In fact, they're already here. So let's not debate that. But there are opportunities for us to be more productive, more creative, more equitable, more healthy, more productive. Right? So if we do this right, I'm with Ayana. I think this has an opportunity for us to actually become richer as human beings. But it's not a given. In fact, I think one of the things that worries me a lot is we're seeing a big disconnect or a big division between certain, for instance, schools where kids learn computer science, they grow up being robo-literate or computer literate, and we see others where they're not. And that is creating, I think, a real disconnect, because with every disruption, there are going to be people that are disrupted. And if you're not well prepared, then it's going to be a rough ride for a while. I think just like when the computer came, it was a rough ride for a while, and then we became better or richer as human beings. But I think we have an opportunity to steer the development, we as technologists, but also policymakers, to make sure that we end up in a situation where we are better for it as opposed to worse.
Okay.
Do you mind if I throw something in there?
Please.
Every time I say something, he throws something in there.
No, yes and no. But you know what I don't like about the whole discussion is always we have these, and sorry, in that case, it's mostly, it's those neo-wise men. You know, we have Elon Musk, Stephen Hawking, unfortunately no longer, and Bill Gates. And they all say, robotics and AI will destroy humanity.
And they're not roboticists or AI folks
Exactly,
either.
Yes.
exactly. And you know what the problem is? people out there, and we already touched upon it, are either afraid of robotics, so they believe the Terminator is looming around the next corner, or they're excited by science fiction and they think that Jetson's Rosie, Data, Wall-E, or whatever is looming around the other corner. Both is not true. As we said, robots can walk 15 minutes, they tumble over. It's not at that stage yet. And that leads actually to the core of that fear, because people are either believing those people stoking fear or the Hollywood effect. And I think it's not really healthy, because it's the same thing. Imagine you're in Africa, and when you look out of your tent and you look into some gleaming eyes, you should be afraid of a lion. Check. If you're in Times Square and you're permanently afraid of a lion, you should talk to your psychiatrist. And I think this is exactly the problem where we're just going wrong. We're shifting the baseline.
So I see that there are the
Sorry.
two extremes,
Yeah.
and really we need to maybe find some place in the middle
Yeah.
to look at. Let's talk about ethics. So doctors have a Hippocratic oath to do no harm, essentially, to heal people, to do no harm. Do we, as researchers, as roboticists, as manufacturers, as policymakers, have a moral and ethical responsibility to make robots that do no harm?
Yes, yes, we
go ahead.
do. Sorry. No,
Go
yes,
ahead.
we do. Well, you know, it's a hobby of mine to look into that. And so currently we're working on what we call a robotic and AI manifesto, because we believe we need a common set of rules. And as I said, sorry, I'm a computer scientist, it has to be a prime number. So like the 11, 13, or 17 rules of robotics. Because I do believe in self-regulation in the beginning, because before you go into a hard regulation, making up laws, that mostly inhibit innovation usually if you do them in the beginning, I think we have to start with self-regulation. We have to involve all the stakeholder groups, and we need something that I like to call robotic governance. So I think we need governance frameworks for robotics and AI, and we have to discuss those matters. Yes, I fundamentally believe it's important.
Because currently, it's pretty much the Wild West.
Yeah.
Yeah, it is.
It's like the internet.
But
Yeah.
going back to the mega trend that we started with, which is the robots are leaving their cages on the manufacturing floors and entering our daily lives. By virtue of the fact that they've started to engage with us more and more, they end up in situations where one could call the decisions they're making ethical decisions. Right? And I think maybe you've seen these, you're in a self-driving car and there's a kid crossing the street. Either you'd run over the kid or you crash into a tree and kill the driver. Which one do you do? And that's an extreme example, but right now that decision is made by a 22-year-old dude in Stanford writing an if statement, right? Or somewhere in Silicon Valley. And maybe we don't want that. So the question is, what does it mean to build ethically, let's say, certified or cognizant robots? Are there going to be, different kinds of robots depending on what ethical system you follow? Maybe, but I do think that we are going to have robots that end up in situations where they make decisions that if a person made those decisions, we would say that's a moral decision. And it is complicated. I actually agree that as researchers, we have a responsibility to think through what it is that we're unleashing on the world and do it carefully. I don't know if you saw, so Microsoft, 3 years ago, they launched something they called Thai Tweets, which was a Twitter bot it was an AI on Twitter. And this thing was designed, it was very cuddly. The first tweet out of Thai Tweets was, humans, why can't every day be National Puppy Day? Very nice and cuddly, right? And less than 24 hours later, they had to pull this thing off the internet because it did things like, and this is a quote, in all caps, wrote things like, Hitler did nothing wrong. So in less than 24 hours, this thing that had learned from people on the internet had become a racist, anti-Semitic asshole, I think is the technical term.
From the internet, really?
Yeah, on the internet.
People.
How could that
And that's
happen?
problematic. And people were egging it on, but at the same time, that's what you learn. If you just learn from us, we are not necessarily good role models. And, that also becomes a little complicated. If you have a self-driving car, some of you, I wouldn't like my self-driving car to learn from because, right? But you can learn from maybe others. So we do have a responsibility to also unleash algorithms that learn within reason to avoid certain type of biases, so that they don't become bad robots.
Yeah, so I think there's two parts of the equations in terms of what our responsibility is. So this is the first time in history where engineers and computer scientists are asked this, right? Before, it was like, oh, you do a good job, you create a cool gadget, you get paid, and you didn't have to think about the moral implications of your code. You didn't 10 or 15 years ago. You took an ethics course and someone talked about Freud or something, and you're like, oh yeah, I got my A, and you're done. And this is the first time that we're seeing that as scientists, we're called on to be ethical, which is hard. We're not necessarily trained. So computer science, every single computer science student at Georgia Tech has to take an ethics course. We've been doing it for years. And yet we still see things going on in Silicon Valley that we're like, how did that happen? We're just not prepared yet to teach our students. And therefore, I think our technology has to have some responsibility. I mean, how many of you code, right? If you put in, like it used to be when we started coding and learning how to code, you would get penalized if you had to compile and it didn't compile, right? So you were very careful about making sure it compiled first. Now kids use the compiler to basically like, oh yeah, there's my error, let me fix that. Oh, there's my error, let me fix that. I think we can have like an ethical engine that says, hey, before you deploy me, maybe you should think about this right here. It's kind of wrong. I think we could do something like that in terms of our technology, and then also train some of our engineers a little bit better in terms of what it is.
The problem is that the systems evolve over time, right? That's what makes it complicated.
Values evolve over time.
Values.
Societies have different values, whether you're in Europe or Germany or in the US, even slight differences in values.
So here's a business model, right? You get a priest, a rabbi, an imam, and a philosopher, and you start a robotics ethical certification company, and you can have a certified kosher robot or a certified.
I thought you were going to have the world's first robot. A priest and a rabbi walk into a
Started
bar.
as a joke, but
robot
it
joke.
Yeah.
That would be
robot,
amazing.
That will be a nice Twitter contest, actually. We should,
We'll have to workshop it.
Yeah.
Do we as humans have a bias against robots? For example, perhaps technically speaking, and I think my experience having a self-driving car and talking to self-driving car experts is that it's likely that the car can perfectly drive and stay in the lane, but it's our bias, particularly as Americans, that we don't want the robot to drive for us. We want to have the car as a symbol of freedom. And so we don't want to give that up. Are there similar things where we as humans have a bias against a robot which may be perfectly competent to do a job, but we just don't want to let them do it?
I think there are things we enjoy doing as human beings, right? I just like there are artisanal, handcrafted Italian shoes. I think in the future there are going to be artisanal, handcrafted holes that are dug by people because we like digging holes sometimes, and it's a more expensive hole than the robot hole. But so I don't know if it's a bias, but I think there are things that give us meaning and value and joy in our lives, and there's no reason to think that robots are going to deprive us of those. In fact, I'm working with a German car manufacturer that it's an upscale brand, and they sell a premier driving experience. And they asked the question, what does a premier driving experience look like when the cars are self-driving? And their take on it was, people are still going to buy this particular car because they like driving. So they're going to drive it. And then there are things we don't like parking. Parking sucks. So you get out of the car, you press a button, and the car goes away. So I think we're going to see a lot of these kind of things on top of it. But if people like driving, I do not foresee a future anytime soon where we're not allowed to drive anymore.
Dominic, what about a medical application, say?
Yes, yeah. I think in the medical field, it's, sorry, it's after lunch, but not too many gory details, I promise. So if you do knee or hip replacements, what currently still happens is that you hope that your your surgeon is very good at handicrafts because they cut it on site. So they look at the bone and say, yeah, I think it fits like that. That sounds scary, and sometimes there are mishaps happening. You could automate that, and you could make it fit 100% if you do the cutting with the robot. People would never feel comfortable with that, even if the robot would never make a mistake. So the way to go around this now is, so I said before, robots can now feel forces. They can also generate forces. And what you can do is you can remote guide that bone saw, and if you're about to do a mistake, the robot will realign in the last second and will basically guide your hand, but the surgeon is still the one cutting, but the machine is actually helping. So that makes people usually far more comfortable, and it's the thing. I think the reason is humans always have to be in the loop, and humans always have to be in control. I think the problem starts when we start tricking them, because when we pretend they are in control. And I don't know if you've read about it, but a while ago it went through the press that in many of those elevators, the buttons to open and close the doors are actually not wired. They're only there for us to feel comfortable that we could influence what the elevator is doing. Yeah, well, in that case you're laughing because it is not life critical,
Right.
but
it's human nature.
Exactly, but for other systems, you want to be in control. You want to have that magic red button, and you want to be able to stop everything. And I think this is really important to keep people in the position that they control the machine and not the machine is controlling people.
Fair enough. Ayana, keeping humans in the loop?
Yeah, I think it's almost necessary, even if you quote-unquote trick them. So, for example, there's been a lot of issues with privacy and security and things like companies. And so they've done experiments where they said, well, what if you could take away your bias bubble, right? So I get, say, my feed from groups that I don't necessarily associate with, and so I have a different viewpoint. I'm going to give you that choice. And do you know, as soon as people had that choice, they were like, oh, no, I don't like this. Like, I want to go back, right? But they had the choice, and that's really what it is. It's about having the choice to make a decision, even if at the end you're actually doing everything that the robot and AI system knew you were going to do. I think that's just our human nature.
I think it also has to do with that we always impose a free will into things. So the human wish for anthropomorphism. And, well, I think you all know that. Who of you has ever yelled at their car, their PC, or their smartphone?
Oh, yeah.
So, yeah, because they always do that intentionally. And by the way, you can run an experiment, and sorry, Grant, I have to get up for this for a second.
Okay.
So you can do that. Those of you that have a vacuum cleaning robot, invite people for a party, let the robot run, and give them 3 or 4 beers or alcoholic beverages of their choice, and then see what happens. So as soon as the robot gets caught in the corner, they're going to talk to it like a dog. Because the robot is back there, and they're going, well, Robbie, what did you do? Come here, buddy. And it's a robot. It cannot hear you. It's, I know. Come here. Come on. It's completely, but that's what people do.
I go back to my definition of a robot. If you talk to it, it's a robot.
You're right. But
you yell at it.
But that is actually why I think that, for example, industrial robots shouldn't have faces or eyes, because if something goes wrong, we always impose that it was intentional. And
Wow.
Yeah, because
Yeah.
But-
Why
but-
did you trick me? I knew this.
exactly.
But there is one domain where this question is actually becoming rather pressing, and that has to do with military applications. So right now, there is a person that makes the kill, no kill decision where we have drones flying somewhere other than here with munitions on them, right? The robots or the drones are not allowed to make the determination by themselves whether or not to drop the load. And I think we should be pleased with that. But there is a question, why? Why aren't we allowing them to do this? Is this a line we're willing to cross? And in the robotics community, this is a big discussion now. Are we willing to let automated algorithms make that kind of life and death situation? And so far, most of us feel rather queasy about that. But
not all of us.
But not all of us.
I feel queasy, but
yeah, no, and queasy doesn't mean a hell no. It means, yeah, let's. But there are also countries, for instance, where there are no such problems right now. And there is this technological race that's going on between different cultures where it's hard to defend, for instance, against a swarm of killer drones flying towards you. That's just complicated to defend against. So in this particular domain, it is a real question, which is, should people be in the loop, even though it makes us feel better, but this may not be the right thing to do. For instance, if we could have wars with no people ever dying, if it was just robots fighting robots, that would be amazing, right?
Right, but people would say, no, absolutely not.
Yeah.
And yet
Actually,
you think
let's
about
not-
all the soldiers that are killed, right? And yet we still don't want robots. And again, it's something personal. Even though robots, there's researchers who say, well, robots can be programmed without emotions, right? Like mine have emotions, but we can program out emotions. And so it's just I analyze, I see someone with a gun way over there, and I'm going to shoot them, right? Like a robot can actually do that better than a person.
Yep.
And yet we still don't want that to happen because there's something about the moral issues of killing someone.
You know the joke about the ideal manning of a modern aircraft? You should have a pilot and a dog, and the pilot's job should be to feed the dog, and the dog's job should be to bite the pilot if he or she tries to touch the control panel. Have you heard that? Yeah.
We don't deserve dogs.
No.
No.
No, but there is a question, right? There are things that robots actually do better. In fact, I am perfectly happy to have the lane-keeping feature on my car take over every now and then when I'm swerving, right? That's, in a way, a life-and-death situation where I'm perfectly comfortable with having a robot, in this case, actually nudging me back in the lane. No problem with that.
Cool. All right, we are going to open up in a minute to questions from the audience. We have a big, that cube thing that's going to get thrown around. While you're thinking about your questions, I'm going to ask one more, which is, what's the biggest obstacle currently to advancing robotics technology? It could be a tool, a resource, a component. Bear in mind, you have representatives of all the major component manufacturers as a captive audience in this room. So if you have something that you're thinking of, and I think I'll start, to echo what Magnus said earlier, it's battery technology for me, for mobile robotics, because that's what limits the ability of our robots to interact with people, with objects, with the world. And it also limits the abilities of the actuators. You could have the most powerful actuator in the world that your robot could run 30 miles an hour, but you'd be done in 2 minutes. So I think that, and as well as computing power to power vision systems for processing. So that's my personal ask if anyone can help out.
I second that. Please do that.
Yeah.
Yeah. I mean, you named the top two, batteries
Yeah.
and computing power.
Yeah.
I mean, we
Well,
can make up stuff.
I think we can also add everything that helps manipulation, which is either you invent something to get the mass out of the system, that would help a lot, or that actually helps us, for example, motors and gears, very small motors and gears with high torque, very long lifetime, and well, yeah,
Which is
it's
power.
again cheating physics, I know, but it's...
Yeah, that's been the thing particularly for manipulators, because as you get all the way out at the end where the fingertips are, any weight that goes out there makes it so much harder for the rest of the system. And so yeah, we've always been chasing tiny servo actuators that are the ideal thing. And until you get that, all your motors have to be further in, and you probably use cable or something like that to remotely power.
It's hardware.
Yeah,
Yeah.
hardware.
Hardware.
Yeah.
So, I mean, we can eat bananas and bread and whatever. Our digestive tract is remarkable, right? I mean, I would like that. I would like robots that I can feed food.
A
Yeah.
biofuel robot.
Because we are just so good at turning stuff we find laying around into energy.
And we're amazingly energy efficient. So
We
for
are.
example,
Yeah.
usually in presentations, I like to play around with things in my hands. That today would need 2,000 watts and 4 quad cores to run that. and I'm not talking about
Just your hand
balancing-
gestures?
Yeah, just to
Just to
play
do this.
around with something. Our brain can do whatever we do right now with about approximately 200 watts.
Yeah.
And you have to imagine that. And this is including the calculating power. And that is why we're so much advanced and why robots are not there yet. It is simply,
That's
it's
right.
damn hard.
Isn't it 40% of our energy is spent up here? And
Huh?
But yeah, I mean,
Yeah.
think about it. As humans, we have two dexterous manipulators
Yeah.
that can work in concert without crashing into each other. We have a binocular vision system. We have binocular, stereoscopic auditory capabilities. And all this processing happens in real time. And furthermore, if you are, say, on an assembly line and you need to move a person, you can just move them to another station, give them a day to teach them, and they can adapt. Whereas reprogramming a robot would take, and power source, you need infrastructure for a robot. You need high voltage, high current lines. Humans, most of the time, they bring their own lunch. So it's when you weigh those against human versus robot, humans still have a lot of advantages. So, okay, let's open it up to questions from you guys. If you have a question, raise your hand and we'll find you with the cube.
Can you hear me now? All right. Anybody? Oh, cool. So
Yeah.
you spoke a little bit about this robotics manifesto. Do you not think that's already out of the bag with companies like Boston Dynamics and robotic drones and being used for military purposes?
Actually, so what I do know is that all the biggest robot manufacturers in the world, and by the way, we run that through a neutral foundation. We took that out of KUKA so that it's not biased in any way. Sure. And all the large robot manufacturers actually signal that they are very much willing to sign something like that when it comes up. And I have been talking to Boston Dynamics, and they are even actually also interested in that. And also, especially because you just raised the name, Boston Dynamics is actually the example we have been tapping upon, because what you see in those videos shows you that this is something that is fully autonomous, working in every terrain, limitless, and all that. The truth is, 15 minutes, it has currently still to be remote controlled by 9 people, and it's not autonomous, and it can just perform that one task that you see in the video. So I don't think that it's too late, but we should start thinking about those implications. And actually, right now is the time for that, because I think you said it before, I don't want to end up in the same situation like with the internet. The internet just happened, and nobody could have imagined that 12-year-olds can no longer survive without cat videos at the bus stop. And well, it's the truth, come on. And I think we still have time, because as we also said, hardware is much slower than software. We have still another 20, 30 years, and we should use them. And this is why I want to talk about the fundamentals now. And currently, I get a very good positive feedback from governments, policymakers, European Union, White House, IEEE, and also from industry. So I think now is the time.
I think, there are other programs that are working to build this idea of responsibility as well as cooperation. I know we have a FIRST team in the house. Is that correct?
Yeah.
So FIRST Robotics, if you don't know, but probably a lot of you guys do know, is a international high school robotics competition. And what they do is give them a cooperative goal every year. And so the students have 6 weeks to build a robot. I was a mentor for 4 years. They're paired with people from industry, people like us, to help them build this robot to do some cooperative challenge. And part of that, what they instill in the program in the students, is this idea of gracious professionalism, of helping each other, of cooperating. And in fact, as you get to the further rounds of the competition, you cannot win alone. In order to win, you have to be paired with another team and cooperate together. So I think that from a grassroots level, there are these moral values being built into our future engineers and scientists. Hopefully that goes further.
But I also, if I may jump in a little bit, so I think your Boston Dynamics question is really good, because they have built a series of rather remarkable robotic platforms, but they're not contextualized in the sense that they're not yet deployed in any particular context, in any particular culture. And I think, I mean, ethical questions they emerge when you contextualize things. So at this point, they have built a really remarkable platform, and when I now deploy it in, let's say, a subway somewhere, and either it pushes people onto the tracks or it saves people, that's when the moral decision shows up. So I don't see that as the cat being out of the bag. It's clear that the cat is peeking out of the bag, but it's not too late to train the cat.
Yeah, there's still time, but the time to start training is now. Next question? Yes.
First of all, this has been crazy interesting. I appreciate what you guys have done. But one of my favorite science and technology quotes is something Carl Sagan said about never before has society been more dependent upon science and technology, and so few people understand science and technology. Is it important? Do we need to? Or is it okay for us to depend on you guys to understand it and set the course? I mean, how important is this? And in context of when you think about our institutions, the big institutions that govern our lives all predate technology. You know, to a large extent, education, certainly religion, government. What do you guys think about that?
I personally, I'm an educator. I personally think that everyone should be trained in understanding the basics. And so, we learn how to read, we learn some basic math. We should learn things like coding from very early on as part of our curriculum in engineering. I think that as the world continues to evolve, these will be just as important as being able to read a sign, to be able to program your favorite Rosie that's in your home at some point because it's not doing right. I think it's a responsibility we have as a society, as engineers. I think that's why most of us are involved with teams like FIRST, because that is a mission that we all have.
Yeah.
I also worry, so first of all, if we're the only ones that understand it, that's good because it's job security, right? But beyond that, I worry that, so take self-driving cars right now. There's tremendous confusion about it, and people say autonomous driving and no one knows what that means, right? So there is level 5 autonomy, which is a car that can drive like a human being in all conditions. We're nowhere close to that. Level 4, level 3, maybe we're 2.5 right now, meaning sometimes in curated conditions the car can do almost as well as you, something like that. But people are having opinions about it. People are passing laws about it. People are making decisions that impact our lives based on a profound misunderstanding of where the technology is. So I don't need people to be AI experts, but I do think as a society that's getting more and more technological, it's important to have just an educated citizenry that understands what technology can do and what it cannot do in order for us actually to be a little bit rational about how we structure our society. So I don't need you to program self-driving cars, that's okay. But I do need you, if you're going to be in a position of power, to understand what they can and cannot do. So that's my view on it.
We're living in the Anthropocene, so in the human-made
In
age. The Anthropocene.
Okay.
So it's humans and technology that is shaping the next 20, 50, 100 years. That said, I want to actually turn it around. I think for us as technologists, it is our responsibility to start being able to explain technology, because that is something that lately, I had a great discussion with the deputy director of the UN Institute for Disarmament Research, because they're discussing about should we ban autonomous weapons or not. And she said a really great thing. She said, we would wade in technology experts that can explain technology in an understandable way to policymakers in gold. We don't find them. They have this technobabble, they talk like a scientific paper, but they're incapable of explaining technology in a way that the general public or policymakers can understand it. And I think this is also something that I would like to teach or seen being taught at universities, how to talk about technology. And the reason is very simple. I believe that our grandchildren will grow up as the first generation are of robotic natives. This will happen. It's the kids of my son. And the moment that happens, robotics and automation will be everywhere, and they're no longer being afraid, but they still have to be capable of understanding that. Because you know what we are? We're robotic immigrants with a very analog migration background, but we're gonna see this in our lifetime. The shift is going to happen now. And if that does, we can now sit there and say, oh yeah, let experts do the talking, or we should get involved, and I'm perfectly with you. I think it's crucial that we understand what's going on.
It's absolutely essential to have a population that votes on various issues understand science and technology. And as you said, you don't have to be the programmer of the electric vehicle, but having that basic understanding, I think, is so vital. For a decade on Mythbusters, that was our struggle. We were essentially a science show that explores urban legends using the scientific technique. And one of the reasons why the show was so successful was that the way that we approached explaining the science wasn't a traditional clinical way with formulas and proofs and things like that. We used to wrap our science in a delicious candy coating of car crashes and fire and explosions. But nonetheless, it was a part of our way of getting that science across to be able to communicate these concepts. And people would essentially learn the science without even knowing that they were consciously learning something scientific. So it's essential for us, I think, as technologists, to be able to have that context, to be able to explain, to break things down in terms that people will be able to take away and understand. Yes? Yep.
Is this on?
Yep.
Hi, how are you? A question and a comment. Somebody had mentioned about limitation of battery power in robotics. What is being done to look into, regenerative kinetic energy? I know there's that in some vehicles, but how about with other moving parts, industrial, what have you? You have gears, everything that you can, instead of taking that energy from heat, convert it to a recharging circuit and recharge the batteries. What's being done out there?
Yeah. I think the efficiency, the loss of efficiencies, or getting your efficiency higher is a pretty big challenge, which...
Yeah, and we're seeing it in like MEMS devices, so microelectronic, small devices, right, where energy harvesting from kinetic energy is beginning to no longer be something weird that only worked once in the lab somewhere, right, and actually being more mature. But the scale is so small that it's hard to scale up yet to something that can power a sizable robot. But there's absolutely no point, for instance, that I walk around with my phone in my pocket all day. Why do I need to plug it in? That seems like a complete waste. And I think 10 years from now, we won't plug it in, because that's a small enough device that the technology is actually there for doing energy harvesting from the kinetic energy. But scaling it up, we still don't know how to do.
It'd have to be a massively parallel, maybe tiny wearable piezoelectric interfaces that you could then harvest that energy of motion, but we don't currently have that technology available.
So micro robots we can do. Real big robots, absolutely not.
Thank you. The second is just a comment that hit me when you were talking about, say, robotics in a life-death situation, or going out there instead of man forces to bomb. And I've always had interest in robotics. Where I feel we can't replace robotics by humans cannot be replaced is that we have a certain amount of, after logic comes our affinity and our spontaneity. And logic can say ones, zeros, yes, no, go, and go hit that button, but it cannot, in a millisecond, in itself, feel I can't do this, or it's not right. So my comment there is I don't see how we can totally replace the human aspect. Any comments to that?
I'm with you. So human beings, we're remarkably good at dealing with uncertainty, first of all, and something like situational awareness, where we just have all these things coming at us, and making reasonably good choices based on rapidly evolving uncertain data. We're not there algorithmically yet. And also what you're saying, this ability for us to say, dude, I don't actually know what to do here, or this doesn't feel right. We don't have algorithms for that yet. So with you, I echo what you just said.
All right, I'm going to
Diana,
take...
are you going to disagree? You look like
No.
you disagree.
So the question is, and I would say maybe it's under intuition and these aspects, I don't necessarily agree that we can't get there, right? I would say that right now we don't, but I don't think it's because we can't. I think it's that, there's not a body of researchers that have been like, we're going to try to figure out what is intuition in terms of what does that look like in people and how do we learn it and things like that. So that's
Yeah, that I agree with too. There are no profound theological reasons why this cannot be done. We're just not there yet.
Right.
What about intuition? What about creativity?
Yeah, I think that's a tough one because first of all, it starts with what you define as creativity. And there are all these cases going on like, picture editing programs getting much smarter. You just press a button and they do the creative part of the work, but is it really creativity? Is a filter creativity?
Right.
I don't know. Building something out of its own has not been shown yet, but I think same logic applies. We don't know if we can do it. I'm more on the skeptical side, to be honest, if we can. But I think in the end, it's always left also to human interpretation. If we accept that this is creativity, maybe it's just something that we attribute to humans, because usually we also don't attribute it to animals.
Right.
And there have been those cases, and so elephants
Cat
painting
videos.
or something. Yeah, exactly. And so I don't know, but I think it's similar to what you just said.
Although, there was a robot AI agent that won for script writing, like recently.
Uh-huh.
And so the question is, how do you define that? I'm not quite sure.
I think it's simple. Robots are creative when we say they're creative. Done.
We can redefine
That was
based on what we have.
a very creative solution.
There you go. Okay, I'm going to take the last question as we're getting close to the end here. I'm going to flip the doomsday scenario and go towards a positive. What is one thing that you think, that you look forward to robots helping humanity with, to go beyond our limitations? And I'll start. For me, it's space exploration. Before sending people to Mars, we have no idea what we're actually getting ourselves into. And so we have Mars rovers, there's another one going in 2020, that are gathering information for us. And it's not to say that this is limiting humans, but it's a way of not risking human lives where we don't have to in order to gather information and to explore space.
Well, you actually partially took away mine because I wanted to say everything that's where it's dangerous for people to go, so like disaster recovery and things like that. But
nuclear
it's the same
cleanup.
thing like space. So let me put up another one. It's actually in the household. If you ask people what they want a robot for, even in Germany, and Germans are very innovation averse in that field, they say 60% say, I want a robot that does the dishes, does the laundry, and they're even willing to spend up to 29 euros for every additional hour of spare time a day. So if you look at that, I think that's something that people just want.
Yeah.
I think it's enhanced quality of life with respect to like exoskeletons and prosthetics and all these things that we're going to need. Just so you know, right now the stats are, for most countries, you will spend 8 years of your life with a disability, whether it might be a mild visual impairment or cognitive impairment.
Yeah.
So I want a robot for when I'm there, right? That's what I want. I think a lot of us do.
Yeah.
Yeah, and in fact, I have glasses. Had I lived 300 years ago, I would have been eaten by a wolf by now, right? And now this is nothing. And I think, in general, thinking of orthotic and prosthetic devices, making our lives better, making us be mobile longer, making things like, the fact that this body deteriorates not be an obstacle to going on with your daily lives. I also, as a short male, I want to be able to dunk a basketball. And
Oh, yeah.
I see no reason why I shouldn't in a year or 10.
People ask, would you get a robotic body? I would say, hell yes. I can't wait
Yeah.
to have my awesome robotic body. Well, if you've enjoyed this and if you would like to see more content in depth with me or any of these panelists, you can go to Mouser.com. We have an excellent 5-part series called Generation Robot, where we talk about all of these concepts and a lot more. I'd like to thank my panelists, Dominic Bozel from KUKA, Ayana Howard from Georgia Tech, Magnus Egerstedt from Georgia Tech also. And my name is Grant Imahara. Thank you so much for joining us.
Thank you so much.